Welcome to the College Scientist. Really quick, we're going to highlight how these Lewis structures can help us with some of the common elements found in organic chemistry. Although some of these are obviously not organic molecules, they provide a good basis and a good foundation to understanding future organic reactions. Now, ready to start off, over here we have two hydrogen um, elements and two hydrogen atoms, you can say, and each of them carry one uh, valence electron, in any way, just one electron. And one of the best ways to provide the stability for each of these hydrogen um, elements is to form a covalent bond where they share these electrons. And basically, this line right here represents that bond between these two electrons. They're shared in a sense. This provides enough stability to uh, this molecule right here involving these hydrogens. Next up, we have chlorine. Chlorine typically likes to have six valence electrons that are free, meaning that they're non-binding, and usually it likes to have, obviously it wants to have this full octet. However, it only has 7 valence electrons. Hydrogen has one valence electron, and if it donates this valence electron or shares it in this occasion particularly, then it forms a single bond here, and it provides stability to both of the elements. As you can see, these different valence electrons are not highlighted in this chlorine molecule. However, um, it can you can suppose that they are actually included, um, although they're not represented in this image right here. Next up, we have water. Water is very crucial. It's it's involved in a lot of reactions that we will also talk about in the future. So what um, essentially what we have is this oxygen that has these 6 valence electrons, and then these hydrogens that have each one valence electron, you can say, and these essentially bind in different ways to these oxygen to provide enough stability for it. This oxygen ultimately is going to want to have two pairs of non-binding electrons. So what occurs is that these hydrogens bind to one electron here, and then maybe another electron here, um, and they form these single bonds, while this will eventually leave this right here. So we're going to have these 4 electrons that are available, that are just non-binding electrons, and that's very essential for oxygen. And you're going to see in a lot of the different reactions that this is the most stable form of having this oxygen element in regards to valence electrons. Now moving on to an actual organic molecule. Um, it has carbon in it. It's carbon containing. We have methane that's represented right here. And how it comes about is essentially you have 4 hydrogens that each carry one valence electron, and this carbon typically likes to have 4 binding sites to its element, to itself. And as you can see, each carbon here, the one carbon, pardon, actually carries 1, 2, 3, 4 electrons with, and then it can bind to each of these, 4 um, um, hydrogens to give away this methane molecule. Single bonds right here. And these all satisfy the octet and provide stability to the molecule. Now, nitrogen. Nitrogen, really quick, just going to highlight that it's a neighbor to carbon, actually. Carbon has these 4 valence electrons. Nitrogen has 5 valence electrons. What this means is that typically nitrogen likes to have just one lone pair of non-binding electrons outside of the sphere of the binding one. So what we have here is actually we have NH3. What occurs is each of these hydrogens obviously carries just one electron. Each of these binds to a respective electron, pairs up with one of the valence electrons from nitrogen, and it forms this NH3 molecule. Even these two electrons as a lone pair that are non-binding, and this provides a lot of stability to the nitrogen. And these are basically just some of the basic, crucial, you can say, elements and patterns in bonding that are very present in organic chemistry. Feel free to review this video as many times as you need to understand just some of the basic patterns. If you have any questions, feel free to email the college scientist. Our email is attached in the description. I'm sorry, the about option in the channel. But with that being said, thank you for watching, and we'll see you in the next video.